Pete, it's 12 months since we met up at PowerGen last year.
Yep.
What have you seen going on in the energy industry in the past 12 months?
Well, it's certainly been an impactful and exciting last 12 months. So in terms of the energy industry, if I look back even just 12 weeks, we had a blackout in the UK. So 500,000 people without homes in one of the most reliable, stable grids in the world.
Yep.
In March earlier this year, we had blackouts in Australia, and then the week after, 2 weeks after, negative power prices. So this whole world of renewables generation rightfully coming first, and then the need for reliable generation is really starting to play out. And that's what we see with our own assets and with clients' assets around the world.
Now, with the platform that we were chatting about, you've continued developing that innovation. We were chatting earlier, you mentioned that you've kind of seen the way people are looking for value.
Yeah.
I don't know, people are getting a bit more impatient, they want to see value now, or?
I think that there's two major facets to that. Is one, digitalization is promised so much. It's this kind of like great thing, and AI and digital twins. Digital twin, I really don't like that word. For me, it means so many different things to many people.
Yep.
But the reality is that they've kind of been burnt a little bit, and a lot's been promised by software, whereas actually what you really need is the people alongside that. So we had a hypothesis and a belief last year that actually we had to deliver all of this alongside engineering competence and service.
Yeah.
And that's now for us been proven the case. So with the clients we've acquired over the last year, the differentiator has been the engineering knowledge. Not just giving them a piece of software, giving them a CD, as you termed to me earlier, but actually saying, right, okay, so there's an engineer that helps you build the models, that then explains what do they mean, that provides consultancy on top of that, because what Uniper has is this 40, 50 years of generation experience in the most complex, diverse markets with regards to renewables and market regulation. That knowledge is extremely useful and helpful to other people around the world starting to experience those changes.
Right.
And when we're able to do that, we've been able to get clients payback within 2 months, 3 months of purchasing these things. And that, for us, has been the difference, whilst also not creating frustration through false alarms and incorrect information, which does kind of degrade the quality that people expect from digital solutions.
Now, a lot of the value add you guys bring with your platform is the fact that, as you say, you've been running power plants for X amount of years, you've got all this expertise. Yet when I go out, I go visit power plants, whenever, everybody tells me, oh, well, my power plant's different. So, so you can bring in all of this knowledge, and I suppose, I know, is AI the right word, but the algorithm or whatever. But I'm guessing you still have to, this is where the engineering expertise comes in, you need to be able to map it to that plant's world.
Yeah, there's definitely a truth in that. And I recently wrote an article on LinkedIn about this as to why the kind of digitalization of perhaps the retail sector or more repetitive manufacturing hasn't translated into power generation. And for me, it's two major things. One, AI needs lots of data, information, repeat things to learn from.
Yep. And
power generation assets, thankfully, we don't have lots of major failures. For good reason. They're unsafe things, and with safety and safe operation is at the number one of any owner and operator's addiction.
It's
so
top of the priority list.
Absolutely. So taking risks around them is a very considered thing. So if you consider that there's not enough failures, you can't then use a lot of these neural networks, like things people use for character recognition and videos, all that. You can't use that same approach, and that's where the engineering knowledge comes in. The second thing is, I mentioned about failures and it being unsafe. You've got a situation where these things are extremely high pressure, extremely high temperature. They are at temperatures and pressures that are not commonly occurring throughout the natural, at least the surface of the plant.
Yeah.
So they're inherently very dangerous things as a result of that. So whenever you're doing any changes to an asset, you have to understand the physical impact you're having on that, because the cost of it, the risk of life, etc., is extremely high, and that's different to you routing a car on Google or predicting what cluster a retail person's going to be in. If you're wrong, the implications in the retail world is quite small, but in power generation, the risk and the impact is quite significant.
And you know, worst case scenario is that there's failure and somebody gets hurt. The better case would be, well, the power plant just shuts down, but then that costs you money and whatever, right? And the lights go off somewhere because something else doesn't spin up, you know, whatever, right? It's complicated, right?
Yeah, and that would be against kind of what we really stand for, Uniper, in the sense of delivering the energy transition. It's about decarbonisation, it's about security of supply, it's about the cost of that. So anything that would go against that would not fit in what we're trying to help people achieve.
Now, in your platform itself, I've been following you guys for the last 12 months. You brought up a bunch of new modules, capabilities. What's going on there?
So with this kind of change, or at least crystallisation in the market around flexible operation, we brought in some creep life and fatigue life monitoring. So when you start to change how your asset operates, then the impact on the metals material maybe in states there they previously haven't been, or we don't know what's going to happen when they go to those states. Thankfully, because I work with another 250 engineers who specialise in integrity, have done all the studies from the CGB days through R&D, through research, we've got the proven engineering physics base behind that for the maths. So when you then apply that to the data from the sensors, from temperature, from pressures, we can tell you how much life, how much remnant life you're using up of that component, and therefore the level of risk you are carrying with that. So when you combine that with advanced condition monitoring that I talked about last time and performance monitoring, you start to get a very good understanding of health and the risk you're taking with your asset. And that's just another example really of the combination of engineering and digital together.
Excuse me, because I think it was last year when I was here chatting with you and others, I had kind of assumed that, well, okay, I have a power plant that's running 24/7, 7 days a week, 365 days a year. That is wear and tear. But it can actually have more wear and tear if you're turning the thing on and off.
Yeah.
So if I have a gas peaker or whatever, and I'm, oh, well, I need it now and I don't need it tomorrow, and I'm turning it on and off, that has a whole different characteristic on the metal fit, all sorts of things. And that's where this comes in.
Yeah, exactly. So if you think about when you're starting up an asset, if it's coming from coal, those changes in metal temperature, the rate of change, the absolute temperatures at a base load is reasonably well managed because people are trained.
Yeah.
So they're trained about the starts, the stops, the cycling.
That's what.
Yeah. So to give you an example, in the UK last week, I think every single coal station on Tuesday morning was running. Last week in the UK, yeah. So not all units, but every single station had at least one unit running.
Going.
If you go back 3-4 weeks before then, no real coal station had ran for significant periods for about 12 weeks. So then not only that, now these units over the last 2 weeks have been doing sometimes 2 starts a day because they're catching the 6 a.m. to 7 a.m. before an 8 a.m. now, pushing 9, before the sun comes up and starts giving all the solar input. And then they're coming back on at 5 p.m, 6 p.m. when the sun's gone down. So they're doing 2 starts. There's these kind of 2 shifts.
And they, as you say, when they were designed, it was like you turn it on, it runs. But so it's the hot and cold and the whatever. And it was I'll tell you, it was a new word for me. So you called it creep life.
Yeah, creep. So creep is the engineering term really for what happens to metal when it undergoes change at heat. And that, if you go too fast or too high, effectively that eats life away of your material, and then you get creep-induced failures.
And this is where your entire preventive maintenance schedules and whatever, that all starts changing and potentially.
Potentially, and if you run that alongside advanced condition monitoring that I talked about last time with anomaly detection of faults, you can start to get a good idea of kind of what health the asset is in that state.
Now, you also mentioned to me earlier, you've done some more stuff on feature detection.
Yeah.
But, I'm a big features guy. There's always a feature with something. But what in your world, what is feature detection?
So feature detection, really, it's a data science term for identification of a feature in a data set.
Okay.
And really what we use it for is automated diagnosis. So anomaly detection, fault detection is a well understood, well proven, successful method in power generation. But what a lot of people are struggling with is you can get a system to do that, but it then fire lots of false alarms at you. And maybe only 1 in 10, 1 in 20 of those is real and useful. So you end up having a whole person's job is to kind of manage all the nonsense and the alarms. We mitigate that historically by providing a monitoring center.
Okay.
And we still have a monitoring center that we provide to clients. But over the last 10 years, because we've recorded every single fault that we've ever identified on a power plant through advanced condition monitoring, we have like kind of a list of pseudo failures, or they're a set of faults. And from that data set, we have identified a set of fault signatures which match a certain feature set, hence feature detection. So it allows us to do a form of automated diagnosis. So in that sense, you could say it's kind of starting to enter the real AI world.
Yeah.
But you'd only ever be able to get there if you have a massive
data set,
which is what I was talking about at the start. AI needs tons of data. It's not like humans where we can just identify that a duck-billed platypus, for example, is clearly a different type of animal, whereas AI would be like, is this thing a chicken? Is it a duck? Is it an otter? What is it? Whereas we know as humans.
One of the most fascinating things I came across in the past 12 months was a company that were using gaming software to create hundreds of thousands of images of distribution line equipment, and they were training an AI on faults for video recognition or the image recognition, because they just said we can't get enough pictures of what's good and bad, so they were using gaming technology to create pictures of the environment.
Wow.
So now, different world, but
it's
back to the I need so much data for the AI to learn.
Yeah, correct. And speaking of image detection there, we have done, because we've got 30, 40, maybe even 50 years worth of boroscope inspections on GTs. Okay. So on all the gas turbines, in terms of detecting corrosion, that's historically been done by a visual inspection engineer. They'll watch the video or they'll do it live and they'll say which blade needs some attention.
Because the guy has the knowledge over years, right?
Exactly, and that is still incredibly powerful. But if you think about the decreasing expertise in the industry in general, as people retire, as actually new blood doesn't come in because they choose to go to financial institutions.
Perceived sexier places to go?
Yeah, there is. But if you want to make a real impact on the world and deliver an energy transition, then this is the place to work. But we've got all this information, all these videos, and we have then been able to use effectively a set of neural networks, artificial intelligence, to train what corrosion looks like, where it gives a percentage score per blade. So this level of accuracy is effectively
within the turbine.
Within the turbine, so it's more consistent than a human being. It gives an empirical answer, and then when it's really bad, you get a visual expert to actually look at it. So it focuses them on the key
stuff
problem
that they need besides.
Exactly, yeah. And that's just another example of where, when you combine that with the engineering knowledge and things like parts lifetime extension, so extending the gas turbine by 10,000, 15,000 hours, you need to alter your maintenance and your inspection patterns to operate that safely. Boroscope inspections and visual inspections increase when you do parts lifetime extension, because you want to you're running into a space which is potentially riskier, so you have to do more inspections. Okay. Well, using AI to help with that inspection
speeds it up,
provides maybe a level of consistency and a safety net alongside the experts. It certainly doesn't replace them today.
No, but Otherwise, somebody's sitting at a lot more photographs, and that can get a bit boring after a while.
Yeah, exactly.
And just mental fatigue, right? It's human nature.
Yeah, there's plenty of studies into how judges make decisions based on time of day.
Fine. Yeah. The soccer match is starting. That's grand.
Exactly, yeah.
Okay, hey, anything, what do you expect in the next 12 months in the big world?
In the big world, I'm expecting that we should see a lot more understanding of how digital, a general industry acceptance of how digital makes the difference. And for me, it's in what I've talked about, the combination of engineering and digital, not just a tool that does magic.
Here's an IoT device, plug it in, and you're done.
Yeah.
Here's the CD, install that, and send it to the cloud, and we're done.
Yeah, exactly.
So
then we've gone up the top of the hypercurve, we've come down into the valley of tears, as I think it's called, and now we're onto the kind of real benefit side. So we'll see that, and the world will continue to drive a decarbonisation, as it rightfully should do. And with that comes increased flexible generation, greater challenges to the economics of existing assets, and I hope that, and strongly believe, we will be a part of helping the world deliver its energy transition as a result.
Hey, good stuff.
Pleasure.
Good to see you again.
And you.
Thanks a lot.